Okay, so in this example, we're asked to find a linear approximation for some nonlinear function f of x near x equals a. And we're given that the value of the function at x equals a is f of a, and the value of the derivative at x equals a is f prime of a. Okay, so we need to use this to find some sort of a linear approximation to this function. So, well, a linear approximation is just a line, which means that if it's a line, then it has to have a slope. And that slope is the derivative of the function. We're going to set it equal to the derivative of the function. So f prime at a, if we let y equal f of x, right, then f prime of a is effectively approximately equal to the change in y over the change in x at that point, right? And we're going to let that be the slope of our line. Okay, so if I rearrange this delta y over delta x is equal to the slope m, then I get delta y equals m delta x. Okay, so delta y is the change in y, and we've defined y to be the value of the function, so I can actually replace this as f of x minus f of a. Okay, it's a change in the function. And m is f prime at a, and delta x is x minus a. All right. So now I can rearrange this into, and I probably should make this approximately equal to, right? Because, we're modeling a nonlinear function. And so if we want to find the approximate value of f of x using this nonlinear function, we can add f of a to both sides, right? So we get f of a plus f prime of a times x minus a. Okay, so that gives us a formula for the linear approximation of f of x near a. Okay. Now I'm going to go ahead and do example 3 because it's related. It's closely related, and we want to also write a formula for the error, a function for the error, right? We want to formulate e of x for the error. And the error is just going to be the difference between the actual value of the function and the value of the linear approximation. So all we're going to do is we're going to define e of x to be f of x, so that's the value, the actual value of the function at x, right, minus the linear approximation, which we have a formula right here. So it's f of a plus f prime at a times x minus a. Okay. Now we can rearrange, we can distribute this negative sign if we want to. So I can, let me do that. We don't really have to, but because this is a perfectly acceptable formula. The key thing to remember though is that the error is just the difference between the actual and the estimated value, right? So I could also write this as f of x minus f of a minus f prime of a times x minus a. I think that's the way they have it written in your book. So there's a formula for the error function. Either one of those will work. But I summarized that information down here in this box. All right, so if we want to find a linear approximation to a function around a certain point, x equals a, then we can approximate it by if we know f of a and we know f prime of a. And the error in the function is just the difference between the actual and the estimated value. Okay, so I will meet you for the next example.